Before the lecture, we asked members of the audience what questions they would like to ask Stephen. And of course, the questions came flooding in. So we've chosen a small selection of those questions, and we gave them to Stephen ahead of time so he could program the answers into his computer. This is done word by word by Stephen manipulating a small detector in his glasses by moving his cheek muscles. So it's a slow process, so we're very lucky that he's privileged that he's able and willing to answer some questions. So the first question is from Elson Badrakataj.
Yeah,
thank you. Sorry.
Can you hear me? Can you hear me?
That's better, yeah.
Good evening, everyone. Good evening, Professor. I'm sorry, my question is slightly off topic, but I couldn't help it. I got the chance to ask you a question, and I'm going to take it. My question is, do you think artificial intelligence will one day take over? And I'm hoping you're not going to give me just a yes or no answer. Thank you.
I think there's no qualitative difference between the brain of an earthworm and a computer. I also believe that evolution implies there can be no qualitative difference between the brain of an earthworm and that of a human. It therefore follows that computers can, in principle, emulate human intelligence, or even better it. Up to now, computers have obeyed Moore's law, which says that computers double their speed and memory capacity every 2 years. Human intelligence may also increase because of genetic engineering, but not so fast. The result is that computers are likely to overtake humans in intelligence at some point in the next 100 years. When that happens, we will need to ensure that the computers have goals aligned with ours.
Thank you, Stephen. The next question is from Alfredo Carpenetti.
Good evening. Thank you for the amazing lecture. My question is, what do you consider is going to be the next big discovery from the Large Hadron Collider?
The hopes for the future of the Large Hadron Collider include the possibility that it will discover both supersymmetry and the true nature of dark matter. So far, there has been no sign of either of these showing up. It will be even more exciting if something unexpected is found. And if neither supersymmetry nor dark matter is found, it will be a tremendous opportunity for theoretical physics.
Thank you, Stephen. The third question is from Sergio Iliev.
Good evening. Thank you for this truly unforgettable lecture. It is a great honor to ask you, what work are you most proud of? Thank you.
I would like to be remembered for my work on Hawking radiation and entropy of black holes. It is summed up by a simple formula, which expresses the entropy in terms of the area of the horizon and the three fundamental constants of nature: c, the speed of light; g, Newton's constant of gravitation; and h bar, Planck's constant. I am proud to have discovered it. I would like this equation to be on my memorial, like Boltzmann and his formula for entropy.
Thank you. The fourth question is from Noah Howard.
Good evening, and I'd like My question is, which big questions within the field of physics do you think will get resolved in the next 10 years?
My work is in gravitation and cosmology. So for me, the priorities would be more sensitive satellites to observe the cosmological microwave background, and further observations of gravitational waves by laser interferometers, both on Earth by the LIGO experiment, and in space by LISA. Measurements of the cosmological microwave background will enable us to test key predictions of inflation, the theory that the early universe had a period of accelerated expansion. More observations of gravitational waves will allow us to detect supernovas and black hole or neutron star collisions, thereby testing our understanding of strong gravitational fields.
Next question comes from Amin Ben Brahim.
Hello, Professor, and thank you for this truly memorable lecture. My question is, do wormholes exist, and what would be their significance?
Can space and time be warped enough to meet the demands from science fiction for things like hyperspace drives, wormholes, or time travel? Wormholes are hypothetical tubes of spacetime that might connect different regions of space and time. The idea is that you could step into one mouth of the wormhole and step out of the other mouth in a different place and at a different time. Wormholes, if they exist, would be ideal for rapid space travel. You might go through a wormhole to the other side of the galaxy and be back in time for dinner. Rapid space travel, or travel back in time, would require matter with negative energy density, which doesn't seem to exist. Wormholes would lead to information lost down the tube, and can probably be ruled out on those grounds.
And the final question this evening is from Sabian Rankin-Hart.
Good evening, Professor. A truly unforgettable lecture. My question to you would be, do you have any advice for young people who want to become theoretical physicists?
It is a great time to be alive and doing research in theoretical physics. My advice to young scientists is to be curious and try to make sense of what you see. We live in a universe governed by rational laws that we can discover and understand. Despite recent triumphs, there are many new and deep mysteries that remain for you to solve.